In this video, we'll go over pOH calculations, which are identical to pH calculations. Specifically, we'll go over the calculation of a pOH value of a solution given the concentration of hydroxide ions. After knowing how to do this, we'll also be able to calculate the pH value of a solution given the concentration of hydroxide ions. So that means we'll be able to calculate the pH value of a base, basically, which we couldn't have done before. Remember this pH chart? So I actually hid the other half of it. This is also a pOH chart at the same time. pOH measures the amount of hydroxide ions in a solution. It's basically the reverse numbering of the pH scale. The lower the pOH value, the more basic it is. The higher the pOH value, the more acidic it is. Take a look at the chart to see this relationship. Calculating pOH, or the concentration of hydroxide ions, is also pretty much the same as calculating pH and the concentration of hydrogen ions. I want you to note the similarities of those equations. Finally, there's one more equation you should know. This one's easy. pH plus pOH equals 14. Always. Look at the pH scale again. Anywhere on the chart, if you just add the pH value and the pOH value, it's always equal to 14. Isn't this a pretty neat coincidence? Okay, so we've got 3 examples for this video. In this first example, what is the pOH value of 5.8 times 10 to the negative 2 molar solution of magnesium hydroxide? What we should already do is write down the pOH equation. pOH is equal to the negative log of the concentration of hydroxide ions. What is the concentration of the hydroxide ions? Is it this right here? Well, it usually would be, but I want you to take a look at the substance here, magnesium hydroxide. Each molecule of magnesium hydroxide, how many hydroxide ions does it have? Well, there's 2 right there, so each molecule of magnesium hydroxide has 2 hydroxide ions. So if we have 5.8 times 10 to the negative 2 molar solution of that molecule, magnesium hydroxide, then the amount of hydroxide ions is going to be double this number. It's going to be double that. So in a calculator, how do we get double that? Well, we're just going to do that number times 2. So in a calculator, 5.8 E negative 2 is equal to that. So we're going to get double this, so times 2 is equal to that, 0.116. So the concentration of hydroxide ions is actually 0.116. So we're going to plug that into the equation. And then we're going to type this in a calculator to get pOH. So in a calculator, we want to first put in the number 0.116. I already have it in mind. So now all I have to do is get the negative log of it. So hit the log button first, and then get the negative of it by pressing the plus minus button. So that gives me a pOH value of 0.94, essentially. So that's the pOH value. And you might be wondering why it's so low, but this is pOH. Remember, for pOH, it's the reverse of pH. The lower the pOH, the more basic it is. If you wanted to know the pH, it's actually really simple. I'm going to just do a side note for this. So, side note. Here's a side note. We should already know that pH plus pOH is equal to 14. Well, to get pH, if we know pOH, then we can get pH really easily, because they should add up to be 14, right? So what does pH have to be? You can probably figure this out, but I'm just going to do this mathematically. I know that pH, we don't know yet, but pOH we know is 0.94. So plug that in. Just solve for pH, just subtract 0.94 from both sides. On the left-hand side, 0.94 and negative 0.94, they become 0. On the right-hand side, they subtract. So what we should get is pH is equal to 14 minus 0.94, which is going to turn out to be 13.06. So the pH value is 13.06. This is a high pH value. And it makes sense because we're dealing with magnesium hydroxide, which is a base, which should have a high pH value. Here's example 2. What is the hydroxide ion concentration of a solution that has a pOH value of 5.6? Okay, just write the equation down. Concentration of hydroxide is equal to 10 to the negative pOH. Okay, we have pOH. Do we just plug it in? Yes, it's that simple. You just plug it in. So the concentration of hydroxide ion is 10 to the negative 5.6. Now you just type this in a calculator. In a calculator, you type 10 first, and then you hit this button, to the, and then put negative 5.6. And now we're going to get this really small number, 0.000025, essentially. What is the concentration? So it's that, and then the concentration should have unit of molarity. Okay? All right. That's it, and this is the answer. All right, this is our third example. What is the pH of a solution of 1.2 molar solution of potassium hydroxide? Okay, this is actually a little bit roundabout. So we're trying to get the pH of a base. We've never done that before. To get the pH of a base, you might be thinking, okay, pH is equal to the negative log of the concentration of H+, right? But we can't get the concentration of H+. This is a base. It produces hydroxide ions. So our idea is that we want to get the pOH first, and then since we know that pH plus pOH equals 14, we can get pH then. We're going to eventually use this equation, pH plus pOH equals 14. But we actually want to get pOH first. Okay, so pOH, can we get that? Well, yeah, it's equal to the negative log of the concentration of hydroxide. Can we get the concentration of hydroxide? Yes, this is a base. And for potassium hydroxide, each molecule only has one hydroxide ion, right? So that means this concentration is the concentration of hydroxide ions. So pOH is equal to the negative log of the concentration of hydroxide, which is 1.2 molars. So type that in the calculator. We type 1.2 first to get the negative log of it. Hit log first and hit the negative button. What we're getting is negative 0.079. That's the pOH. Okay, we got pOH. To get pH, we want to use pH plus pOH equals 14. So pH plus pOH. Now pOH is a negative number, so minus 0.079 is equal to 14. Right. Now to get pH by itself, we get rid of the negative or minus 0.079. So add 0.079 on the left, but also on the right side. On the left side, the negative and the positive, they become 0. On the right side, you actually add them together. So what we should end up with is pH is equal to 14 plus 0.079, which is 14.079. That's our pH. You might be wondering, wait, the pH is bigger than 14. How is that possible? Yeah, it's actually possible. You can actually, okay, side note, you can actually have a pH value that's lower than 0. You can actually have a pH value lower than 0 and greater than 14. Now I want you to try this practice on your own. Just a heads up, this one's a little bit challenging, so take your time, try to work through it with the equations that were shown to you at the very beginning of this video, and try to persevere. And then in about 5 seconds, I'll show you the answer for this. And here we go. The pOH turns out to be 13 For this problem, you can't solve for pOH directly because we're trying to get the pOH of an acid, and an acid doesn't have hydroxide ions. So you have to get the pH first. Get the pH of the acid, and then we should know that pH plus pOH equals 14, so you can figure out pOH after you get pH. Alright? I hope you found this video helpful.